Hello friends, welcome to my YouTube channels. Today I am going to discuss heat transfer problem. Today I am going to heat transfer problem by the conduction mode. So what is the questions given here? A composite wall consists of 10 centimeter thick. One wall thickness is 10 centimeter. Building brick. It's a thermal conductivity. K thermal conductivity given 0.7 watt per meter Kelvin. And another block thickness is 3 centimeter. That plaster block. Whose thermal conductivity 0.5 watt meter Kelvin. Case 1. Then case 2 what is there? One insulating materials of whose thermal conductivity is 0.08 is to be added to reduce the heat transfer. So two wall is there. Wall 1, wall 2. Case 1 will find the some data. I think temperature difference will find. Then again one more layer, that insulating layer they will fix, that is called third layer. Then how much thermal conductivity will reduce, heat transfer will reduce, 40% heat transfer will reduce. Then what is the thickness of the insulating wall? So that only they are asking. So see here, case 1, what is given? Two wall is there, two wall will be there, one brick, one plaster. Two wall is there. One wall is brick, one wall is plaster. Which thermal conductivity, brick thermal conductivity will be given 0.7. That is called K1. Then 0.5, that is called K2, thermal conductivity. And thickness they given 10 centimeter. So 0.1 meter. And another thickness is 3 centimeter, 0.3 meter. So okay, the given. Temperature not given. So that maybe the temperature we have to calculate first. So case 1, two wall is there, whose thermal conductivity and length given. What they are asking? Case 2. Case 2 they are asking if the same wall, brick and plaster, if they will add one insulating material, insulating wall, whose thermal conductivity will be 0.08, that is called K3. 0.08 K3. Thickness they are asking. This already thickness we know. 0.03, 0.01 meter. This K1 for brick, 0.7, K2 for plaster, 0.5, that is given. So case 1, case 2. First case 1 what will find? Some unknown will find, then we'll substitute this, we will get the answer. So see here, two wall is there. So already you know, Q is equal to, here Q1 is equal to, if heat flow rate you are assuming Q1, suppose Q1 is 100. Because the given no loss, heat transfer, reduce heat transfer 40%. So Q1 is 100. Then what will the Q2? Loss is 40%. So 60. Q2 will be 60. Q1 will be 100. Then Q2 will be 60. So okay. So what is the Q formula? Temperature difference. Temperature not given. So we'll write in delta T. Then what is thermal conductivity for first layer? First layer we know L1 by K1. A not given now, assume A is equal to 1 meter square. So I am not writing here. Plus L2 by K2. One wall, temperature difference L1 by K1. Second wall, just add. Third corner will add like this. So Q is equal to how much here? Given 100. Delta T. Then substitute this value L1, 0.1 by 0.7 plus 0.03 by 0.5. If we'll substitute, if they'll solve, this solve and multiply 100, this will get delta T. This will get delta T. How much value is there? I already calculated, I kept ready. So delta T is equal to 20.28. 20.28 Kelvin. How much delta T coming? Case 1 T. Now same delta T will use here. Then what will be the formula for the Q2? This you give Q1, okay? Q2. What will be Q2 formula? Again delta T, but here 3 layer is there. One brick, one plaster, one insulating layer. This is nothing but insulating layer, okay? This is brick. This is plaster, okay? So now again L1 by K1. I'll write directly, okay, write one more times, L1 by K1 plus L2 by K2 plus L3 by K3. So we'll substitute the value. What is the value here? 60. Because 40% loss, so this is 60. This is taken, suppose heat flow is 100%, then loss is 40%, then how much remains? 60%. So 60 delta T. Delta T already we know how much? How much we know the delta T? 20.28. 20.28 divide by, what is L1? 0.1. Same things we'll write here. 0.1 by 0.7 plus 0.03 by 0.5 plus L3 is unknown. Then we'll write thickness is, conductivity is 0.08. That is the value. So once we'll calculate this, we'll get the L3. So we'll write somewhere problems. I will going to rub it. I'll rub it this question. Now I'll write here what is this 60 into this. Okay. So first what we'll write here? This part will write 0.1 by 0.7. How much? 0.1 by 0.7, 0.143. 143 plus 0.1 by 0.7, 0.143. 0.03 by 0.5, 0.06. 0.06 plus 1 by 0.008, what? 12.5. 12.5 L3 equal to this by 60. 20.28 by 60. 20.28 by 60. Then this will calculate here. This part will come, this will add, and this value, so 12.5 L3 is equal to this 20 by 28. How much coming? 20 by 28. 20 by 28 is coming 0.338. 0.338. So L3 is nothing but 0.338 divided by 12.5. So you will get the value 0.135. Just 1 minute here, calculations will be what? 33, no? So this 333 minus 0.143, 0.06 you have to minus. So it will come, this will calculate, just 1 minute. We'll calculate this. 0.143 plus 0.06 is coming 0.203. It's coming 0.203. If we'll subtract this 0.338 minus 0.203 equal to 0.135 divided by L3 is equal to 12.5. L3 is equal to 12.5. So how much will come L3? L3 value we calculated 0.08. So already we have, we'll divide 12.5. So 0.0108 meter. So this is the thickness of the insulating part. So what we are, this question is telling, if brick wall and plaster wall will be there, if one insulating wall will add, how much heat transfer will reduce? The given 40% loss will be there. Heat transfer will reduce 40%. Then what is the thickness of this they are asking? So thickness L3. This is the thickness of the insulating wall. If this much thickness will be there, then only heat transfer will reduce by 40%, that only this question is asking. Okay. Okay, students, watch this video. Watch this video beginning to end, copy down, and calculations part you revise. Calculations part again you practice. Okay. And subscribe the channel so you can get the new video again and again. Okay. Thank you.